Good morning, good afternoon, and good evening, everyone, and welcome to our webinar, ABB Sick Boosting Cobot Safety and Efficiency. I'm Lucy Fielding, and I'm glad to be your moderator today. We are here to explore how ABB Robotics and Sick have combined their cutting-edge technology to make cobot safety both seamless and highly efficient. And I'm delighted to introduce you now to our two speakers, Erika D'Antonio, Global Technology Manager, Robotics Ecosystem at ABB Robotics, and Marco Sproul, Strategic Product Manager, Integrated Automation at SICK. We are glad to have you all here, and we hope that you find today's session informative and engaging. And please feel free to ask your questions and interact with our experts during the Q&A session at the end of the webinar. So without further ado, please join me in welcoming our first speaker, Erika D'Antonio from ABB Robotics. So Erika, now the floor is yours.
Thank you, Lucy, and thank you everyone for being here today. So let me start with an overview of the ABB's collaborative robotics portfolio, since this will give context to our discussion, especially for those that are new to ABB. So when we look at the ABB collaborative robotics portfolio, our offer is divided into two main families that you can see on this slide. So the YuMi family on the left represent the first cobots we introduced to the market back in 2015. And YuMi robots can handle small assembly tasks efficiently with high speed up to 1.5 meters per second. But on the right, you can see our cutting-edge cobot, GOFA, in three different variants. So GOFA, if you don't know, stands for Go Faster, Go Farther Than Ever. And this cobot has been designed for heavier payload application up to 12 kilogram payload and with speed up to 2.2 meters per second. GOFA can still work in close collaboration with humans thanks to its advanced safety technology, but also to the collision detection. And that's why GOFA represents our gold standard cobots, our best cobots, because thanks to its class-leading speed, safety, and ease of use, will take your business to the next level. But if we talk about ease of use, so our portfolio is not only about hardware, but also about software. And at the bottom of this slide, you can see our ease of use tool, especially I'm talking about Wizard Easy Programming and App Studio that will allow you to easily program and operate your robots and cobots, and using an ABB robot will easy as much as using your mobile phone. If we look at the common cobot application, ABB cobots excel in a wide range of applications. For example, you can see some in this slide. They are good for welding, 3D printing, pick and place, palletizing, and so on. So it comes thanks to the combination of ABB's cutting-edge technology, but also thanks to a robust ecosystem of accessories and software that will lead your automation to be efficiently addressed. But let me explain you better what is the ecosystem program. But first of all, what is an ecosystem? Because we often hear this word ecosystem, but what it really is an ecosystem? Because many people, especially from robotics, will associate this word to something connected with nature. But actually, this is true because according to National Geographic, this term represents the geographic area where plants, animals, but also other organisms, landscape and weather can work perfectly together to form a bubble of life. So when it comes to robotics, it's not something really different than that, because in robotics, this term refers to interconnected systems of robots and different technology. So as for nature, the robot will interact seamlessly with accessory, software, and technology to perform complex tasks efficiently. And if we look to the ABB Robotics ecosystem, as ABB, our ecosystem will provide you with everything you need in order to perform every kind of application. And since the demand for robotics automation is rapidly increasing, but it's not so easy to build a complete robotic application, even if you are an expert, the ABB robotics ecosystem will help you in doing exactly that. So the ABB robotics ecosystem provides you with plug-and-play solution for software and accessories that are ready to be used. And no one will be afraid anymore to automation. And I'm not talking only about cobots, but I'm talking also about robots, because the big value of the ABB robotics ecosystem is that cobots and industrial robots can be programmed in the same way thanks to the new omnicore controller. So what we want to do with you, it's really to drive efficiency together with you. We want to reduce installation and commissioning time and address challenges in automation. So every tool you need to perform your application will be so easy to install that you won't need anymore to spend a long time to install everything. Because sometimes we hear that even experts need so long to install and make it work, every accessory on the robot. So through the ecosystem, this will not be anymore your case. So you will save a lot of time in installing and commissioning time. We want also to get rid of fear of automation and making robotics more approachable and less intimidating while improving production. And finally, through the ABB robotics ecosystem, we are bringing value and quality to your customer or in your production. We will go deeper later on in understanding what is an ecosystem product, but let's see what's in for you. Because if you will buy an ecosystem package, you will get all the hardware you need in order to quick install and make it for the product, including hardware. So for hardware, we mean the main device, clear documentation, but also the cable, screw, and adapter for an easy installation. But also you will find the software package that in ABB is called add-in, that will allow you to program and to make it for the gripper. As well, you will get an interface to simplify operation. So you will be engineered to outrun through the ecosystem program. And that's a bit of the explanation, because ABB robots plus ecosystem products will lead to more efficient projects. It will be easier to start and deploy every tool, but also to operate every application, ensuring your business to stay competitive and efficient. Let's now understand better what is an ecosystem product. If you look at the robotics application, like in this palletizing example, you have the robot itself, but the robot only cannot do everything, of course. So you will have, for example, a gripper, a lift kit, a laser scanner, and a software package, and other tool that needs to be integrated with the robots. Everyone on this single tool will represent one ecosystem product. And if we focus on the laser scanner, that is the focus of this call, in the laser scanner ecosystem package, you will find the device itself, so the laser scanner, but then you will have also the screws, the cables that you will need in order to mount the laser scanner on your application workstation. And you will find all the cable needed for the communication between the laser scanner and the robot controller. But then you will have also documentation that will lead you through the installation process step by step. And then you will have software, pre-configured software, in order to speed up the installation process. the software package and the laser scanner ecosystem kit for GOFA looks like, but later on the Sick colleague Marco will give you more details. So let me add that if you visit our ABB Robotics ecosystem website, you will find two categories of products: compatible products and recommended products. What is the difference? So recommended products are easier to install and to operate. So recommended products are ideal for all users, and it will take only a few minutes to install and deploy the device. Instead, compatible products can be also integrated with ABB cobots and robots, but they are more complex to install and to operate, so they will target experts and system integrators. Both categories are validated by ABB via the ecosystem validation, but recommended products offer faster deployment. And this is how the ABB GOFA safety kit from Sick look like. So we say from 8 hours to 25 minutes, because from 8 hours previously needed to set up the laser scanner, now it will take only 25 minutes. Thanks to this kit that include all the needed cables and brackets needed for you to install the laser scanner, but also you will have all the software elements you need for easy integration and configuration, as well the new innovative software that will be able to automatically scan the safety area, excluding the fixed object. This product is available in 4 variants tailored for cobots. And here a quick video that will show the integration in a machine tending example application. Scanner is a part of the ABB's robotics ecosystem, delivers efficiency and ease of use. But now, thank you for your attention, and I'll hand over to my colleague Marco.
Yes, thank you very much, Erika. And also warm welcome from my side. My name is Marco Spraul, and I'm product manager at Sick and responsible for the S-Board Speed safety system, which we developed together with ABB. So what we developed exactly with ABB is a configuration tool software with a combined and optimized hardware, as you can see it here on the right on the picture. And this configuration tool software allows you to configure up to 2 laser scanners in an easy and intuitive way for your ABB robot applications. We are supporting here 2 interfaces. So one is Profinet and the other one is ProIO. And we are compatible with ABB Swifty and GOFA robots. And at the end, we are allowing with our software an automatic restart of the robot, which is increasing your productivity in the field at the end. And our software runs on a Windows 10-based computer or higher. And what we are targeting with our system are 3 stationary robot applications, as we can see them here down in the pictures, where people can have free access to the robot and walk in, for example, to do a quality check, or for example, for bringing new parts so that the robot can continue with its work. Quickly, some words to safety system. What exactly is a safety system? So a safety system consists out of hardware, There's the laser scanner or mounting brackets, as well as cables, as well as the software. Here our microscan 3 configuration tool, ABB, and the operating instruction, which is explaining you how to use the software. And in addition, we are then using different functions of the Gopher robot, like the force and power limitation, the safety rated monitor speed, and also a safe stop. And how this is working, I'll show you in the next slide. So from Sick on the left side, we are having the microscan configuration tool software. And with the hardware, we are delivering the signals. And from ABB, we are then using the collaborative speed control add-in. And these two softwares are working hand in hand. And this collaborative speed control add-in is then using the sensor signals and then transform it into robot functions. For example, then for stopping or slowing down the robot. Quickly to the function principle. Here I have a short video of a Gopher robot. And here I'm getting closer to the robot. So far we can see on the left side 2 OSSD signals. So we have 2 protective fields here, as you can see. And this is already our configuration tool software. And as I'm getting a bit closer to the robot will slow down. And when both fields are infringed, the robot will stop. So here there's only one field infringed, so the robot will slow down. And as soon as I'm getting closer, the robot stops. So I can check. And if I'm walking out again, the robot restarts automatically again without pressing a button. And then I would say we can directly jump to the live demo. So for live demo, for starting the robot and the laser scanners, of course, we need to mount the laser scanners on the robot table and make sure that they are connected in the correct way and according to the operating instruction of ABB to the robot controller. We need to make sure that we have power supply for the laser scanners. And we also need to make sure that the safe move template is installed on the robot controller, and this can be done via the flex pendant. And so far for the IO interface, there are no steps in Robot Studio needed anymore, which allows a super fast integration. And for the Profinet interface, there we are working at the moment on templates, which will be released in the next 1 or 2 months. And therefore in future, there are no further steps in Robot Studio needed for both interfaces, which allows then again fast integration and more productivity at the end. And the application we would like to rebuild can we see here in the picture. So we have the robot mounted on a robot table, and we have on the left side and right side in front of the table 2 laser scanners mounted. And in the next step, we then can jump into the configuration tool. I did the video here since it's always a bit loud in our robot lab, and therefore I recorded this. So here we are in the user interface right now, and then in the next step we can log in order then to set up our configuration. And now we are in the user interface, and what we can see now here on the left side is the coordinating system in millimeters, and also on the top side. And in the middle, we can see the robot desk as rectangle. R represents the robot, and A and B are the laser scanners. And in addition, we have a menu toolbar on the left side with different menu icons where we can set up different settings. So in the next step, for example, we can set up the size of our desk here, our robot desk. This is already correctly predefined in our case. So therefore, we can then jump into the next step where we can define the position of our robot. Therefore, we took measures in beforehand, so our robot is now a bit closer to the edge. And then we can simply take over these values with apply. And the same we can do with our laser scanners in the next step. So as soon as the laser scanners are correctly, connected to the robot controller, they are automatically found by our tool. And then you can select them and allocate them then to the corresponding position here. And as soon as this is taken over, we have to type in the sensor password due to cybersecurity reasons. And then we can define the position of our laser scanner. And here we are, here we are next to the edge or the corner of the robot table. So we are taking -50 and -50 for X and Y, and then we can also define the rotation in degrees. And this defines with this small arrow we can see here where the laser scanner is looking through. So we are selecting 135 degrees, and now the laser scanner is looking to the left side of the table and the bottom side of the table. And then we can do the same thing with laser scanner B. So we can again assign them to the position B. And place it then in front of the table with the position X and Y. And then also make sure that the laser scanner is looking to the right side of the table and the bottom side of the table. And now, as you can see here in the picture, we have rebuilt our application now, and therefore we can then go to the next step and setting up our protective fields around the robot. Therefore, we go back in the main menu and then select the next menu point. We are having here two kind of field modes. In our case, we are selecting now the robot-centric mode. Regarding the free fields mode, I will say later on some words. So with the robot-centric mode, we have circles around the robot as protective fields. In our case, we have now two protective fields. One is the so-called warning area radius, and the other one the protecting area radius. In addition, we also have a calculation guide implemented in our tool. And this calculation guide allows you to calculate the correct safety distance according to the standard. And we are having here some values grayed out, for example, the approach speed, since this one is fixed according to the standard. But of course, there are also some values that are not fixed that you can change, for example, the supplement for the tool when you have a gripper installed and also for the workpiece. But due to time reasons, we're going not further in details here. So we are selecting 2000 millimeters for the warning area radius and 1600 for the protecting area radius. And now we have two protective fields around our robot. And with apply, we can then take over the values. And in the next menu icon, we can set up some password settings and also define different users if you would like to. But here we continue then and can go in the next step where we can verify our settings we just have done. So we are seeing here again, for example, the position of our robot, the size of our desk, the size of our warning area radius and protecting area radius, etc. And if everything is fine, we then can continue and click on verify. And after that, we can jump into the next menu where we can then scan our application environment with our laser scanners. And therefore, we have on the right side a toolbar. And there we can select after how many seconds the scan should start. So if we are standing in the application area, we can then walk out during this time so that we are not scanned by the laser scanners. And here we are not standing in, so we can select 0 seconds. And as you can see now, in blue, the measurement data of the both laser scanners, and in red, you can see the protective fields with the two circles here. And in addition, you can see that the fields are automatically teached in here by our tool, so you don't need to take care about, for example, some pipes here or wirings or things are standing around like shelves in your application environment. Everything is automatically done for you, which fastens a lot up the process here. In addition, the fields are also automatically split up between the two laser scanners, so you also don't need to care about this. And as another function, oh, sorry for that. I just go back to the point. And as another function, we also have implemented an artificial wall function. And this one allows us to hide some application area which we don't want to observe. For example, when you have some fences installed in your application surrounding where the laser scanner is looking through, or some plexiglass, you can simply hide the area behind it, and then the area is not observed anymore by our laser scanners and is not triggering any robot functions. And if this is fine, we then can simply click on continue. And then we can download the configuration on the laser scanners. And in the next step, we are then seeing again our live scanning data in blue, and also our scene we just have modified here. And on the right side, we have then a commissioning interface with safety relevant measures. Of course, this does not represent a risk assessment, but it's rather can be seen as a guideline. So we would like to give the end user and end customer at the end a good feeling, because when it comes to safety, a lot of people often struggling with it and feel unsecure with it. And therefore, we have different checkpoints. For example, the first one, stepping or staying in unmonitored areas, does not represent any mechanical risk. Or the second one, it's not possible to bypass any field, for example, by stepping over or behind it, etc. And only if you're checking all 5 steps, you then can continue. And in addition, for testing, we also have implemented the OSSD signals here. So in our case, they are both green, so we are not standing in the protective fields here. And after continue, we then can go into the verification report, and then we can activate the safety with our user signature. So we can see again all the settings we just have done, as well as the protective fields here. On the left side, the radius of our warning area and the protecting area radius. And if everything is fine, we can then click on activate safety, and this allows us then to start the robot. And in addition, our verification report is then stored on a C drive in our computer. And as you have seen now, the configuration of our laser scanners took now less than 10 minutes, which then allows you to increase your productivity in the field, since you don't have so much setup time anymore, and allows you to have more production time at the end, which is super nice. And with that, I would quickly jump back to the presentation to explain you a bit more about different features of our tool. So quickly to the modes of application. What we just have seen is the so-called intermediate collaboration mode here on the left side. Here we have 2 protective fields around our robot. And the outer field is used to trigger the so-called speed monitoring. So the robot will slow down. And as soon as a person is getting closer to the robot and infringing the inner field, the robot will stop. And therefore the standstill monitoring is triggered. Whereas on the right side, we have the so-called cooperation mode. This one is only available for the Gopher robot. Here we are having 1 protective field, and as soon as this field is infringed, the robot slows down its speed to a cooperative speed, and then also the force monitoring of the Gopher robot is activated. In addition, we also have different field sets. What we also just have seen on the left side is the so-called robot-centric mode, where we have circles as protective fields around our robot. This is a more easy and fast way to set up protective fields around the robot. But we also have something here which is called free fields mode on the right side, which allows us to define more complex shapes for complex application environments, as we can see it here on the right. And in addition, we can also here define straight lines. So for example, when the robot is only working here on the right side in the back, we can minimize our footprint with such field mode here, which is then also super nice. In addition, I also have another example. Here on the left side, we can see the intermediate collaborative mode. and the free fields mode. And what we are doing here is simply putting some circles into our application environment. So here we have 3 circles in total. And of course, we also can define the size of these circles. And then afterwards, the circles are getting automatically connected to each other to protect the fields. And the fields are also teached in here, as you can see, include the live scanning data. And so you don't need to take care about this anymore. Everything is done automatically for you. And the same we have here on the right side with the cooperative mode, where we only have 1 protective field. And we have placed here 5 small circles, and therefore it allows us also to have really straight lines in our application surrounding. So you can, for example, mark this on the floor in an easy way as well. Then quickly also some words to our offer. We have 4 different safety systems, and they are all tested and also rated by ABB as recommended product on the ABB ecosystem. And we have 2 different interfaces, as mentioned before. So one is the Profinet, and the other one is the Pro.io. And all systems coming with the MicroScan 3, with some mounting brackets, and also with the cables that you can connect them directly to the robot controller, as well as the software. And we have one software for all 4 variants, so we don't need to differentiate between different softwares. And that's it with my presentation. So thank you very much for your attention so far. And before we start with the Q&A session, Lucy will have some questions for you.
Thank you, Marco. Thank you, Erika, for your presentation. So feel free again to send your questions directly in the chat. We will have 10 minutes to answer your questions just after this really quick survey. So I will now share a quick question for you, and you will be able to see it on the screen. So do you have the need for automation with a collaborative or industrial robot in the next few months? And you can see normally everything on the screen, and I will leave you again like 3 seconds, and after I have another question. And again, feel free to ask your questions in the chat, and after with Erika and Marco, we will have some time to answer. Okay, I will close the poll shortly. Okay, and now I have another question for you, but you will be able to see. So, is this safety concept using a laser scanner to safeguard your ABB robot application with an easy and intuitive configuration tool something you are interested in implementing within the next 6 months? And again, you can see normally the 2 responses, and I will give 5 seconds. I can see quite a lot of people still answering the poll. Thank you. Okay, and I will close the poll soon. Okay, perfect. So let me bring Erika on stage. Perfect, because I can see quite a lot of questions, and maybe the first one for you, Marco. Can you share already a local success coming from this collaboration with ABB?
Yes, I can. So we had some customers. They were on a trade show, and they were 1 year ago really having troubles with setting up the correct safety laser scanner configuration, since it was a lot of effort and a lot of manual work. And in this year, we gave them then our new software with the hardware, and it was a lot easier for them. And as Erika already mentioned, it doesn't take them any more hours, but rather less than 30 minutes to set up the full safety configuration at the end.
Thank you, Marco. Erika, maybe one question for you. Is there a validation process for the ecosystem?
Yes, exactly. There is a validation process. So for both compatible and recommended products, we have some requirements, and every ecosystem product that you will see on our website has been gone through this process. And if you want to know more, please feel free to reach out to me, and I will let you know. But so when will you buy an ecosystem product will have be gone through an ABB certification process.
Okay, thank you, Erika. And yeah, I have another question about where can we find more information about the ecosystem and laser scanner, and I guess we can share everything also on the chat and with the attendees after the session. Yeah, Mark, do you want to add anything?
Exactly. You already answered, but there is our ABB Robotics Ecosystem website. We will share later in the chat the link, and there you can find our ecosystem offer.
Thank you, Erika. So Marco, maybe another one for you. What do you like the most about the ABB ecosystem?
There are actually two things I like a lot. So first of all, the user friendliness for the end users. So the ecosystem products are really well tested from ABB side and allows a super fast integration, and also people without any experience can actually set up a robot with its ecosystem products, which is super nice. And the second thing I really like is the good partnership with all ecosystem partners, which are really trying to solve the applications together in the field with a strong back. Okay.
And Marco, because you were speaking, I have another question maybe for you. What do you like the most about the SBot Speed ABB system?
First of all, it's really easy to use. That I like a lot. And it also allows to have a super fast setup time at the end, since we have templates there. So you don't need to set the signals by hand anymore. And this really allows you to set up the safety configuration from unboxing till starting robot in less than 30 minutes. And at the end, I think safety makes with such tools much more fun than it was before, since it's now really easy to use.
Thank you, Marco. During the presentation, Erika, you mentioned recommending and compatible partners. Can you maybe tell us a bit more about this and maybe the difference between the two?
Yeah, sure. So we have the two categories of partner, as I was explained. The main difference between them is really on the ease of use. Both products will be validated by us, but for us, recommended it's really something that can install really quickly, smoothly, and even if you are not an expert. So it's really targeting every kind of user. And we had some examples. So for some gripper that before we needed 2 days to install, even if you're an engineer, an expert, now we take only 10 minutes. So this is really a recommended product. On the other side, on the compatible one, it is something that has been also validated. So it's working, it can be integrated smoothly without any bugs, but you need to have some technical knowledge behind. So it's really somehow that it's more advanced and it's targeting system integrators. We have specific requirements on the technical side, and if you want to know more, we will share with you these technical requirements.
Thank you, Erika. I'm looking at one question from Juho. So does the app provide the reports to be used alongside the risk assessment? Maybe, Marco, if you want to answer this question from Juho.
Sorry, I didn't get the question correctly.
Does the app provide the reports to be used alongside the risk assessment?
So at the end, we are not replacing a risk assessment. Of course, you still have to do a risk assessment. We are giving the end user a verification report of our tool, where you can see all the settings you have done. So in case anything is happening, you can still look it up on your C drive where it's installed. But of course, for risk assessment, it always depends which kind of gripper you have, which kind of workpiece at the end, and we cannot define this in our software in beforehand. And therefore, of course, you always need a risk assessment.
Okay. Maybe, so we have 2 minutes more, I think, for our questions. Erika, if you can give more details about the difference between, I think I've already asked this question, sorry. Which element must be included in the software of an ecosystem package? Maybe Erika.
Yeah, so our software offer includes different elements, but we can say that we have 3 main components. So we have the wizard easy programming, that it's our ease of use programming tool. It's a blockly programming that will be part of your product. So you can drag and drop your programming block, and it's really easy to operate your device. Then we have a web interface, a web app that it's really like the app of your mobile phone. And in this case, the web app will help you to configure your device, but also all the configuration and communication signals needed in order to communicate between the accessories and the robot will be part of this ecosystem product.
Okay, sorry, I will have just one final question because after we are running out of time. Marco, we have one question from Muhammad. How long the lifetime of sick sensor and how to preventive maintenance this sensor?
So the lifetime should be like around 20 years, at least for sick sensors, especially for safety sensors. There are really strict standards that it should last 20 years. And regarding maintenance, of course, when you don't crash the sensor, there shouldn't be anything. Of course, it can be that you sometimes need to clean the lens of the sensor, since when you have dust or something like this in your application environment, then you need to have some cleaning equipment there to clean it.
Thank you, Marco. So thank you very much for all your questions. And with that, I think we've reached the end of our webinar. But if you have any additional questions, please don't hesitate to reach out to us. We will be happy to follow up with you. Thanks again to Erika. Thanks to Marco for sharing your expertise with us today. Thank you all for attending this webinar, and we look forward to seeing you at our next event. So thank you and have a great day.
Thank you for being here.
Thank you.